All right, today we're going to talk about linear functions. We reviewed what a function was yesterday and how to identify one. What essentially functions are things that we can write equations for. If it fails our test for a function, then it also means we can't write an equation for it. So here, we're talking about linear functions, and we've already talked about lines, so most of today really should be review. But a linear function is a function whose graph is a non-vertical line, so all straight lines except for vertical ones. A linear function can be written as y equals mx plus b, where m is the slope and b is the y-intercept. And we should already know that, so that's review. So I do want you to pause and write this down. Okay, here we're going to write the equation for our linear function. So we have y equals mx plus b. So we need to find the slope and the y-intercept. So slope, remember, is rise over run, and your intercept is where it touches your y-axis. So in this case, it touches at -3. Okay, our rise over our run is 1, 2, 3 over 2, so 3/2. So this would be y equals 3/2 x minus 3. So again, we're going to do the same thing over here. Slope is our rise over our run. So in this case, we're going down 1 and over 2, which is -1/2. And our b is where it touches our y-axis, which in this case is -1. So this would be y equals -1/2 x minus 1. So go ahead and pause. Make sure your notebook looks like my screen, and then you can move on. Okay, from tables. So these are still lines, and they are still functions. When you are looking at a table, the pattern should be the same each time. So here our y's are all going down by 2. And that's happening every time. For our x's, they're all going up by 1. Okay, and you do want to check that it's the same every time, because if it's not, then it's not linear. So we'll talk about that more on Thursday, actually, but just FYI, you want to get into that habit now. So our slope is y over x, so rise over run means that we're putting our change in y, or the difference in our y's, over the change in x. So this change is -2. On the top, the change is 1. So -2 over 1 is the same as -2. Your y-intercept is wherever x is 0. So where x is 0, y is 3. That's the point it's going to touch your y-axis. So this would be y equals -2x plus 3. Okay? This is a special case because all of our y's are 2. Whenever you have all your y's are 2, then it's just y equals 2. Or if I had all my x's were 5, it'd be x equals 5. So that's a special case. Okay, again, you want to pause, make sure your notebook looks like my screen, and then you can go on. The last couple of examples we're going to talk about are word problems, or when you would see these things in context. So this first one says, an unmanned aerial vehicle is used for surveillance. The table shows the height of the UAV minutes after it begins to descend from cruising altitude. Write a linear function to model. Okay? And UAV is unmanned aerial vehicle. Okay? So that could be a drone, for instance. A drone is used for surveillance. So this is the height when it first starts, and then after 10 minutes it's lower, after 20 minutes it's even lower. Okay? So write a linear function. So this is going down by 5 for y, and our x's are going up by 10. So my slope would be -5 over 10, and we can simplify that to -1/2, which means it's going down 1,000 feet every 2 minutes. So let's go ahead and put that into context. The UAV is traveling down 1,000 feet every 2 minutes. And I got 1,000 because all of these numbers are in thousands. So this is 65,000, 60,000, 55,000. Okay, our intercept is wherever x is 0, the other numbers are intercept. So in this case, b equals 65. And if we put that into context, we would say the UAV started at 65,000 feet. Okay, at minute 0, at the very beginning, it was at 65,000 feet. So it is important at this point that we are able to start interpreting these things and putting them into words. So we haven't done this before, but that is our next step. Then it says write a linear function. So we are going to write y equals -1/2 x plus 65. That's our equation. All right, we're going to do one more. This one says the cost of buying cubic yards of mulch from company A is represented by the linear function y equals 29x plus 30. The table shows the cost of buying mulch from company B. Which company charges more per cubic yard of mulch? How much more? All right, so they already gave us an equation for this one, and this would be saying that it costs $29 per yard of mulch and a $30, let's say, installation fee. But when it's 0 yards, just at the very beginning, it's a flat fee of $30, and then they charge you $29 per yard after that. So if we look at this one, we have to figure out what they're increasing by. So I'm going to go ahead to figure that out. I'm going to take 82 minus 48.50. So this is increasing by 33.50. Okay, and then on this side, it's increasing by 1. So my slope is going to be 33.50 over 1, which is the same as 33.50. Okay, and this means that it costs $33.50 per yard of mulch. So let's go ahead and write that. Per yard. Okay, $33.50 per yard of mulch. Okay, and then if I wanted to find what it would be at 0, let's just squeeze a line in here. I could take 48.50 minus 33.50, that would be 15. So their flat installation fee is $15. So let's go ahead and put that here. B is 15. The flat fee is $15. So in context over here, this was $29 per yard and a flat fee of $30. This is $33.50 per yard and a flat fee of $15. So this equation would be y equals 33.50 x plus 15. Okay, then let's make sure we're answering our question. So it says, which company charges more per cubic yard of mulch? We would say that company B does, because company B is $33.50 and company A is $29. So we're going to type that or write that. So company B charges more, and then it says how much more, and we can take $33.50 minus 29, and it's $4.50. $4.50 more. That answers our question. So when you do these types of problems, you want to make sure you know what your numbers mean in your equation, but then also you want to make sure you're answering the questions that they ask, because they could be different. So don't just stop at an equation, make sure you've also answered the questions. Okay, at this point, you can raise your hand and show me your notes, and I will give you your assignment.